Good morning, guys. This is Mr. Shields back again with another video. Today, we're going to be talking about the Pythagorean theorem. So we're going to be looking at right triangles. I have a copy of the notes page for you guys on Canvas. So you can go in there and find that under the assignments tab if you wish to print it out. If not, you can just kind of handwrite your notes along with me. So if we take a look at the first part of the notes page, which talks about the parts of a right triangle here. So if we look at A and look at B, those are going to basically be the legs of that right triangle. Okay, so they're going to be the shorter sides. The longest side here being called the hypotenuse. Okay, and so we're going to talk about what the purpose of the Pythagorean theorem is and then put it into practice with a few examples. So I'm going to do most of the sheet with you guys, but some problems I'm going to leave for you guys to finish up. So what is the Pythagorean theorem? Well, the Pythagorean theorem is used to find a missing side length on a right triangle. Okay? And one way of telling that we have a right triangle, of course, is the theorem itself, which is a squared plus b squared equals c squared. And so we're going to put that into application here. Also, another little indicator of a right triangle, forgot to mention this earlier. If I take a look at that little square here, that's also a little bit of a sign that we have a right triangle. But let's go ahead and prove it. So you're going to get several different types of problems here. So if I look at number one, they're going to give me the different side lengths, 8, 15, and 17, and I have to see if this is a right triangle or not. So what I'm going to do is basically take the sides and put that in the formula here. So I'm going to do 8 squared plus 15 squared equals 17 squared. And so if this works out, when I add these two after I've squared them, they should equal each other. So let's go find out if that happens here. So we have 8 squared, which is basically 8 times 8, or 64, plus 15 squared, which is 15 times 15, or 225, equals 17 squared. And if I do 17 squared, it looks like I'm going to get 289. Okay. And so let's just add these up. So I have 64 plus 225. So it looks like I'm going to have 289 equaling 289. And we know this to be true. So it looks as though we do, in fact, have a right triangle. Okay, let's go ahead and take a look at another example here. Let's look at number 2 here. So once again, I'm just going to square them. So I'm going to have 5 squared plus 9 squared equals 12 squared. Okay, so 5 times 5 gives me 25. 9 times 9 gives me 81. 12 times 12 gives me 144. So let's add them up and see what happens here. So 25 plus 81, that's going to give me 106, equaling 144. So is that in fact true? No, of course it is not. So it doesn't look like we have a right triangle here. So we're out of luck, okay? So I'll leave you guys to do the other 2 examples here. And let's talk about another aspect of using the Pythagorean theorem and some other examples here on this front page. So if I look at number 5 here, we're going to be trying to find the missing side. And the missing side they've labeled here as x. And so looking at this right triangle here, we can tell that that long side is going to be our hypotenuse. So with that in mind, let's go ahead and plug it in our handy dandy formula. So I'm going to have my 8 represent my a squared. I'll have my 7-inch side represent my b squared. And then of course we're looking for x squared. Okay, so now we're going to have to use a little bit of our algebraic skills, but that shouldn't matter. And just as a reference, it really doesn't matter whether or not you choose to have that 7 represent the a side or the b side. It's only the hypotenuse where that really will matter, so be careful with that. All right, so if we take a look here, 8 squared gives me 64. 7 squared is going to give me 49 equals x squared. All right, so let's go ahead and take a look at this. So when I add the 64 and the 49, it looks as though I'm going to get 113 equals x squared. So some people might be tempted to say, oh, 113 is my final answer. But you need to fight that temptation because I need to take the square root of it in order to get my final answer here. And so when I do that, it looks like I'm going to get x equals 10.6. So I know the x side is going to equal 10.6. Okay. I do the same thing here with number 6 here. So once again, looks like we're looking for the hypotenuse, so I'll set it off by itself here. And then we'll square the other side. So 18 squared plus 15 squared equals our x squared. And so if I look at 18 squared, it looks like that's just going to be 324 plus our 15 squared, which is 225 equals x squared. Add those up, and we're going to get 549 equals x squared. Of course, I'm not quite done there. I'm going to have to go ahead and take the square root. Take the square root. And when I do that, I'm going to get another decimal here. For my answer, it looks like x equals 23.4. And I go ahead and round that up. Okay. So let's go ahead and take a look at the back page here while you guys are writing this down. And we've got a couple more examples. We've got some word problems. And then we also have, well, actually not the back page. Let's go ahead on to the second page here, because apparently these aren't front to back. So let's go ahead and take a look here at number, oh, let's do number, I guess we can do number 7. Why not? So let me go ahead and adjust this. Bear with me for a second. So if I take a look at number 7 here, this time they changed it up a little bit. So I see my long side, or my hypotenuse here, is going to be 11. And then they gave us one of the shorter sides, which is 3 here. All right, so we can still set that up. So it looks like we're just looking for maybe the A or the B in this case. So let's start off by saying x squared plus my other short side, 3 squared, equals 11 squared. Okay. So when we go ahead and look at this one here, so I'm going to have my 3 squared, which is basically 9. I'll still have my x squared. 11 squared will give me 121. And then I'm going to treat this like a 2-step equation. So I'm going to subtract the 9. I'm going to end up with 112 equals my x squared. Of course, I'm not finished. I'm going to have to go ahead and take the square root. And I'm going to take out my calculator just for giggles and grins here. And if we do that, I'm just going to take the square root of 112. And there we go. We've got 10.58. So let's just round that and make it 10.6, shall we? So x equals 10.6. All right, so I will leave problems number 8 and number 9 for you guys to tackle. So let's do everyone's favorite word problems. I know everyone's thrilled with those. So let me just do one of the examples here. So if I take a look at number, let's do number 10. It says find the length of a rectangle that has a diagonal of 25 feet and a width of 15 feet. So let's go ahead and draw our rectangle here. And so they tell me there's a diagonal, so I'm going to draw that diagonal here. That diagonal is 25. And they tell me that the width is 15 feet. So it looks as though I need to go ahead and figure out this side here. And we could just label this side X for the heck of it, okay? And so when I do that, I'm just going to go ahead and use the Pythagorean theorem. I'm going to take my 2 shorter sides, square them, add them, and set it equal to 25 squared. So we'll have x squared plus 15 squared equals 25 squared. And then I forget the little 2 here. All right, so 15 squared is going to be 225. 25 squared, it's just going to be 625. And then I'm going to go ahead and just subtract the 225. And so I'm going to have an x squared equaling 400. And once I take the square root of that, then I'm going to be left with x equals 20. All right, so as we take a look at what's next here, there's going to be another assignment that I want you guys to do. It's a stations activity in Canvas that I put up there, just 9 problems. I do want you to go ahead and finish this sheet, but I wanted to make sure that I went over at least one of each type of problem that you would expect to see. All right, guys, look forward to seeing you on the next one here. Bye.